I am Dr. M. Manikam, Assistant Professor at Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So, in this video, we will detailedly discuss about shunt clippers. So, in our previous video, we have discussed about clippers and its types. Series clippers we have discussed in our previous video. So, today we will discuss about shunt clippers and combination clippers. Combination of shunt clippers and series clippers combinations we will discuss in detail. So let's go into the video. So mainly shunt clippers are classified into four types, that is shunt positive clipper with bias, shunt negative clipper and shunt negative clipper with bias. So one by one we will discuss. So first one, shunt positive clipper. So this is the circuit diagram. So we have utilized the shunt positive clipper, that is resistance and diode. So in series positive clipper or series negative clipper, we are using the diodes in the horizontal line, and that is in series, and we are using the resistance in series, and then diode in parallel circuits. Like that we are using in the clipper circuits. This is the positive shunt positive clipper. So here we are supplying input as waveform, I mean sine waveform we are supplying to the shunt positive clipper circuits. So we will get the output like that, that is the negative half will cut off. So the input signals will sending through the that is end A and B, and A is connected with the resistance and B is connected with the diode, positive and negative of the diode. Then output will take across the diodes. So if you are supplying the waveform like that, sine waveform, so the signals will flow through the resistance and diode. So we will get the output of positive half will cut off, and we will get the negative half only as output. So send positive clippers with the bias. If you are the same circuit with the biasing, so you are connecting the positive terminal to the negative of the uh, diode, and negative to the input signals. So we will get the positive half, half of the positive half will cut off, and all other remaining signals will get as a output. So this is the positive bias with the shunt positive clipper. Then negative bias means, so the opposite, the positive half will totally cut off, and the negative half, the half of the negative half cycle will cut off, and we'll get an output like this. Then shunt negative clipper. So we are changing the direction of the diodes. So positive is connected with the input signal, and negative is connected, negative terminal of the diode, PN junction diode, is connected to the resistance. Then we are supplying the input waveform signal, that is sine waveform signal we are supplying. So we will get the output like this, the only the positive half of the cycle. So it is not a continuous output, it is the breaked DC output, like that we will get by using the negative clipper. So if you are using biasing with the negative clipper, so if you are using positive bias, we will get the total negative waveform will cut off, and half of the positive waveform cut off. So starting of the hump waveform only you will get seen from the positive half. So this is the positive biasing. So if you are using negative biasing means, so you will get the fully positive half cycle, then half of the negative half cycle will cut off, and we will get the waveform like this. So this is the shunt negative clippers with bias, positive and negative biasings. So this is the shunt clipper circuits. So next one is dual clipper, that is combination of two, both the shunt and series. So this is the circuit diagram for dual clipper circuit. This is the, so we are using only one load resistance with the input signal, and we are using two diodes D1 and D2. So with the different directions, positive and negative, and negative and positive directions we are using. So we are using two batteries VB1 and VB2. So this is the positive biasing and negative biasing. Both biasing also we are connecting. So if you are connected like this, we will get the output. How we will get the output means. So if you are supplying, sometimes it is desired to remove a small portion of the both positive and negative half of the cycle, means we can use these dual clippers as a circuit for particular applications. In such cases, the dual clippers are used. Okay, so the dual clippers are made by combining biasing shunt positive clippers and biased shunt negative clipper. So combination of these two circuits is called the combination clipper or dual clipper. So if you are supplying the input signal, input sine waveform signal, means we will get the, so we will cut off the positive half of the positive half, and half of the negative half will cut off. We will remaining will get the waveform like this. So the applications of these clipper circuits already discussed in the previous video. So clippers are commonly used in power supplies. We are using used in TV transmitters, and wherever we are want this kind of requirement. Suppose we want some portions will cut off, remaining portion will continue, means we can use this clipper circuit by using the bias and positive bias and negative bias, or with bias or without bias we can use. The combination of these two biasing circuits within dual clippers we are using for need of a particular portion of the signals we need, other will cut off, means will need we can use the dual clippers also. So mainly it is used for the clippers that is used in the noise limiters in the FM transmitters we are using. So thank you for watching this video. Thank you.